Hi everyone. Welcome back to another video. We'll be looking at organic chemistry. So we're still in the section of hydrocarbons. So let's just continue. So today we'll be looking at two kinds of hydrocarbons, right? So the hydrocarbons are called saturated compounds, right? So this is our saturated compound. So saturated compounds are just single bonded carbons. You only have single bonds between the carbon atoms, right? It's a single bond between these two, single bond between these two, right? So this in the molecular formula. So this is that I'm trying to jog your memory on what molecular formula looks like. It will just look like CH4, C3H8, right? The condensed formula. You should be able to write the condensed formula of this, right? So the condensed formula is actually so you're able to start writing it much better from two carbon atoms and upward because for just one it looks similar to what is this, the chemical formula, right? So those are just saturated compounds. When they talk about saturated compounds with saturated hydrocarbons, they only have single bonds between the carbon atoms, right? So when we talk about unsaturated compounds, so these have two bonds or three bonds, double or so for this context of our lessons, let's only consider two bonds between the carbon atoms and three bonds between the carbon atoms, right? So these are non-singly bonded carbon atoms, our unsaturated compounds. So when you try to write the chemical formula, it will look something like this, right? For this is for hydrocarbon in the context of hydrocarbons. So you just have H here, H here, H here, H here, right? And then you have C2H4. Last time with C2 what? H H6, right? And now we're H4. So we're missing two because these ones now you have double bonds there. So let me see. So the other one we have triple bonds. Now the couple bonds are reduced right in number compared to when you only have single bonds because now the bonds are between the carbon atoms, right? So this is the versatility of carbon, right? Can form double bonds, triple bonds, and single bonds, right? You can all they have this all different configurations we use for different uses, right? That's why it's very prevalent in everyday uses and also in living matters, right? So we've looked at saturated and unsaturated compounds. So let's just move into categories of hydrocarbons, right? So these hydrocarbons, when they're single bonded, there's a name for them, right? The group of them, when they're single bonded, and then when they're double bonded, there's a name for them. Triple bonded, there's a name for them. That's where we're gonna end, right? But before we get to that, we would like to able to name them, right? Instead of just having these ones, we can refer to this. Okay, what's its name, right? We don't know it now. We can just call it compound X, right? Let's just say X2 because of those two carbons. And this one we can just call it compound Y2 because it has triple bonds, right? So we don't know their names. How can we name them, right? All of them. So let's just go to the nomenclature of hydrocarbons. Um, naming our hydrocarbons. So so this will be your number of carbon atoms, right? So this will depend on how many carbon atoms you have, the number of C atoms you have, and then the prefix will will depend on the number, right? So if you have one, it will start with meth. The N will depend on how many bonds you have on the functional group. We'll get to what the functional group is, right? It might not be a hydrocarbon, right? If it's not a hydrocarbon, it will be something else at the end. But the prefix will always be meth if you have one carbon atom, right? So if you have two, what is it? If you have two, that's your you have eth, right? And something else. You have three, that will be prop and something else. You have four, that will be bute and something else. So for butane, it's a single bonded. So if you have five, that will be what? That will be your pent, right? Because pent means five actually. So let's just do this, right? So that we don't have a long table. Let's just say if you have six now, what would you have? You will have your X, right? And then that's your prefix because six means X. And seven, for seven, you will have what? Hept, which means seven. So you will have hept, that's your prefix. For eight carbon atoms, so you have oct, oct means eight. And then for nine, also for 10. So for nine, you will have none. Okay, none, which means eight, right? And then, and for 10, you will have des, right? So those are your prefixes when you're trying to name your your hydrocarbons, right? So let's just go to our examples, right? So, also, um, let me see. Okay, so let's just start with alkanes. So different types or categories or groups of so let's look at our groups of hydrocarbons. Let's start with the first group. So the first group of hydrocarbons are called alkanes, right? Because these ones have what? Single bonds. So these are our saturated um so these are our saturated compounds. Okay, saturated hydrocarbons, and we already know what saturated means. Saturated hydrocarbons. Okay, the examples we have been given so far are actually alkanes, right? So these are our alkanes. So our alkanes are saturated hydrocarbons, and this is how they look, right? So when you draw them, they will look like this. You only have single bonds between these ones, right? Right. So those are our alkanes, right? So that will be your formula. So that's actually the structural formula if you remember, right? And so let's just give us ourselves an example. Let's use we love using the three carbon atoms. So let's use it. So this time we're actually also going to name it because we know how to name, right? So let's have our H here, H here, H here, H here, H here. So don't forget, this is the structural formula, which you can write the condensed formula for it as CH3, CH2, CH3. And by now you should know how to write the condensed formula, right? It only just, okay, look at this one, look at this one, and look at this one in that order. Okay, so that's the condensed formula. And then now we have what? We have what is this? We have the structural formula, which is 3H8, right? So those are for alkane. And what is the name of this? Now it has three carbon atoms, right? And then when we add three carbon atoms, we say we'll start with what? We'll start with a pro, right? So it's a pro. Its prefix will be a pro. Um, And since it's an alkane, right, it will be a pro. Hey, actually, it's prop or pro, right? So this will be our propane. It's an alkane, it's a propane, right? So this is our name. So that's what that's what we mean when we say alkanes. So those are our alkanes. They are singly bonded or saturated hydrocarbons. So they also have a general formula, right? So this is one group of hydrocarbons. Their general formula is, we've actually seen this general formula before when I was explaining what general formulas are. It's CnH2n plus 2, right? So when we talk about hydrocarbons and then we talk about alkanes, right? It's a group of hydrocarbons. That group has a general formula. For example, when you talk about a series, arithmetic series. They have a certain group, right? And it's a certain group of number of series, right? And when we talk about the quadratic series, this is math, right? So you also have a different type, right? For example, this TA n plus 1 by D can also be AR to the power n minus 1, right? These are different general formulas. They represent different types of series, right? So that's or number patterns, a different type of number patterns. So that's what we mean in this one when you give it a general formula, right? So which means that if you're talking about propane, okay, prop, three carbon atoms. You have three. How many do you have? Put it into the formula. You know how many hydrogen carbons we have. Okay. Octane. So let's just look at octane, right? So this one will be very, very a good will be a good exercise for us. Octane. So octane is a hydrocarbon. It's an alkane. So this will be. So let's just draw it, right? So we can confirm that that general formula actually works. 1, 2, 3, 4, 5, 6, 7, right? So we have another one. Okay. Structure formulas are nice, but they're very, uh, that a lot of work when you have to draw them because you have to draw everything, right? And it also takes a lot of time. Okay. So and so on. 10. Okay, so those X's represent age, right? I just don't want to waste a lot of time writing ages, but those X's represent age. So you have eight, right? Eight of them. So that means that the general formula will be C8 H. So that's 2 by 8, that's 16 plus 2. So you have 18 hydrocarbons, right? So when they say write the general form, write the molecular formula of octane, right? So let's count them. We have 3, so 3, 5, 7, 9, 11, 13, 15, okay? 17, 18, right? 18. So the general formula works. You can try this on with the CK or the cane, see, and you can also tie it with nanotane, heptane, uh, pentane, butane, all of them. You will see that the general formula actually works, right? And then there's something we haven't spoken about yet. I haven't taught you this. It's called the functional group, right? So this functional group, it's a kind of like a symbol that represents that kind of group, right? So for alkane, this symbol will be something like this. So you see that you have single bonds, right? So that functional group is for alkanes, right? So that is what a functional group is. It's like a logo, right? You see a tick, you know that's Nike. Just do it, right? You see three lines that are decreasing in height, you know that's an Adidas, right? So it's kind of like a logo that shows you what kind of function and what kind of group this is, right? So that's what a functional group is. So let's look at the second category or the second group of hydrocarbons called alkenes. So since now we already looked at alkanes, this will be so simple. So these are unsaturated double bond, unsaturated double bonded or unsaturated hydrocarbons. So these are unsaturated hydrocarbons, right? So, and these are what? They are double bonded. These are double bonds, right? So these ones, let's start with this functional group. So the functional group for alkenes um, will look something like this, where you have this, and then you have these two bonds, right? So you will have your H's there because these are hydrocarbons, right? So that you contain C and H atoms. So that's a functional group. And then the general formula for alkenes will look like CnH2n minus 2, right? So that's our general formula, but we can confirm it, right? So let's just confirm it, for example, by having this, right? Uh, Sorry, and then you have these ones, right? So let's get to it. Um, right. Actually, let's just make it this. Before I'm realizing something, so I don't wanna complicate this for you now. Let's just take it slowly, right? So you will have your H, 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 right? 2 by 2, that's 4 minus 2. So that means so that will be what? That will be what? That will give you, and that will give you 2. So that means that our general formula for alkanes is just CN2N, right? So that's our general formula. So let's just look at the naming. So to confirm this one, to make sure it's correct, let's look if we have 3, right? Um, CH, 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 right? So let's look at our bonds. 4. This one also has 4. This one says 4, right? So you have what? So for this one, we have 2, H what? H4. And for this one, you have 3. How many H's you have? 1, 2, 3, 4, 5, 6. 6. 2 by N, that's 6. So our general formula works, right? So, okay. How do we name these ones, right? Because we know that if you have 2 carbons, so this prefix will be what? Should be the prefix should be eth. You see, if you have 3, the prefix will be prop. Okay, what is the suffix? Is it still propane? No, it's not. Okay, but let's see the naming. So naming for alkenes, we already know what the prefix is. So the suffix, it's an in. You just add an in instead of uh, a in an n. You just add an in, right? Which means that this one will be named. Sorry, will be named your a thin, and this one will be named. What is this? Propin, right? Or um sometimes you will have to specify go where the double bond is. All right, so you will need to name it as prop one in. So this makes sense, right? It's on the first. So this one we don't have to specify because it's only 2, right? So you will have to say prop one in. So that shows you that the double bond is on the first um, uh, form, it's on the first carbon. This is very important when you're trying to draw it because if you don't specify, I can also put it here, right? Does that change the structure? It will change, you condense the structure, right? So it's very important. Talking about condense the structure, how would it look, right? Because now you will have to, for example, last time we had CH3, CH2, CH3. So this was what? This was propane. We knew for propane that this was single bonds, but how about when we have prop one in now? For prop one in, so the connect structure will also show the double bonds, right? If you have a double bond between, so this will be one CH2, and then it will be double bonded to this C, which will have what? CH, no, remember CH, and then double bond, and then singly bonded to this one, which will just be CH3, or you can just remove the single bond, right? You don't have to represent it. So this could also be written as what? CH3, right? So you know where the double bond is. You know, it could also be here. So that's how your contact structure will be written, right? So this is just a summary of how alkenes are. So let's just move to the third one. Am I forgetting something? No. Okay. Let's just move to the third one. If you have many, or if you have other questions, you can put them in the comment section, and then we can also look at them when we are looking at our examples or looking um, at uh, at trying to answer questions to try to understand them more, right? So this is just like a crash course. So let's look at number three. The second group is ethene, right? No, not ethene. Sorry. I'm writing a name now. So these are alkynes. So alkynes, these have triple bonds. Okay. So these are unsaturated hydrocarbons and they have triple bonds, and they have what is this functional group will look something like this. And these ones have three bonds, so it will look like this, and this. That's a functional group, right? That's the logo of your alkynes. So they will look like that. And then the naming, let's just get to the naming first before we move. So that would the suffix now for this one, instead of K, instead of A no E, it will be it will be Y in it. So you see now that the pattern, alkanes, right? So that's how it should be. And then we can also look at how you draw them. For example, let's just look at an example here. Let's look at a ethine, right? So let's look at our ethine. Ethine will look something like this. Let's put three, right? So you have this, you have this, you have this, right? So that's what C2H2. We can look at a second one. Let's look at, let's make it interesting now. Look at but two wine. So for this one too, we also have to specify where the triple bond is, right? So by specifying where the triple bond is, so this one is it's a molecular formula, right? The condensed structure will look something like this. Um, it will be C. Let's see, sorry, CH triple bonds CH. So that's a condensed structure. And then your B2 will be looking like this. So this one single bonded to this one, but this is the triple bond is on the second carbon, right? So you will look something like this. Okay, four bonds, so that's stable. And then you put your hydrocarbons, your hydrogens, right? Uh, oh, sorry, this one, this is supposed to, this is supposed to be built to wine and not a prop to wine. So it will need another C. Uh, okay. So the molecular formula for this one, CH4H what? C4H1 3, well, 3, so that is what? 6. Okay. And then its condensed formula will be CH3, C, and then this is triple bonded to this C, uh, which is what? And then you only have C because it doesn't have an H, so you have another C, which you can separate by doing something like this. That's the condensed formula, right? So what is the general formula for alkynes? So the general formula, um, this one video is a little bit longer than the previous ones, but because we had to cover a lot, right? So the general formula is CnH2 minus 2, right? So this one will be what? So if you have four, right, you'd say 2 by 4, 8 - 2, 6. If you have two, right, 2 by 2, 4 - 2, that's two. It matches with a third, right? So those so let's just do a recap. I think we've gotten everything from this, right? We'll start from where we started. So we talked about hydrocarbons, right? What saturated compounds are singly bonded carbons, and then we'll look at how they look, the structural formula, unsaturated, the structural formula, and then we'll look at the naming, right? So these are prefixes. If you have one carbon, how many? What is the name? What is the prefix? You have two. What's the prefix? Six. What is the prefix? Right? And then we looked at alkanes, right? Because hydrocarbons have groups within them. So the first group is alkanes. These are single bonded hydrogen carbons, hydrocarbons, or just saturated hydrocarbons. This is the structural formula, the condensed formula, and this is the molecular formula, right? And then we looked at the general formula, which is CnH2 n+2. And then the fractional group is that. That's the symbol that represents the group. And then we looked at alkenes. These are unsaturated double bonds. There's the functional group, which is the symbol. And then we looked at the general formula, which is CN2N, H2N. And this is how you write them. And their naming these ones is different to alkanes because you have to specify where the double bond is if you have two, if you have more than two carbon atoms, right? And the suffix will be in, right? So it will be ethene, propene, but you'll have to specify that will be prop one in. The double bond is on the first carbon atom, right? When you're counting from the left, the condensed structure now will include double bonds, right? Instead compared to propane where we didn't have any bonds, we just had your atoms, but now you have to include your bonds, right? And then for alkynes, these are triple bonds. That's the functional group. The naming, the suffix now is Y, right? It will be you have to specify where the triple bond is, right? And that's how it is. That's the general formula. So let's meet next time to talk about to look at haloalkanes, what haloalkanes is, and if there's anything more to add on that and hydrocarbons, I will also add. But this is the when we finish the section on hydrocarbons. Thank you.